So just opening our resource group. As initial step, I'm starting Studio. Meanwhile, let's check for some files. What do we have? This is our regular data lake. Our container is my data for inputs. And the different scenarios of merging activity we have seen in the last class. If schema is different, if schema is same, if multiple files are there, if any file has some extra field, okay, at the time generally your union will be failed. At the time, how to create that field in the first two files. So those three scenarios we have seen. So let me open one file here. Sir, observe here, there are some totally 13 records are there. If you observe all these records, first line is header, second line onwards data. Look at the last column. There is a department number. So department numbers, what are all the unique distinctive department numbers? 11, 12, 13, 13, 13, come down. Yeah, 13 and a 20, 21 extra. Okay. I'm taking one more file, sir. Check, is there any file called department? DEPT. So here 11, 12, 13, these three departments are there, but 14 department is not available in first file. At the same time, 20, 21 departments are not there in second file. Let's keep one more department. I'm keeping 15, let's say for accounts. So in the first file, which is EMP, you have distinctive departments 11, 12, 13, 20, 21. In the second file, I have 11, 12, 13, 14, and 15. So common departments are 11, 12, 13. I want to join these two data sets. Okay, first initially in the initial practice, how to join two files. Okay, because employee is separate for personal information available in employee file, but there is only department number, but departmental information is available in other file. So suppose you want to run a query like select city comma sum of salary from table. Okay, the table is what? EMP. Let's say alias E. Join. Right side DEPT alias D. But city is available in second file. Salary is available in first file. That's why you are joining. Group by where or on. D dot department number is equal to D dot department number. Group by grouping based on city. This is what our query. To get city based separate aggregations. But whenever suppose in the aggregations, there are two columns are involving. One is grouping column, second one is aggregated column. Whenever you want to generate a grouping aggregation like that, every time you need to apply the joins. Suppose think that this data is already pushed into your synapse tables. Whenever you want such kind of analytics, city based total salary budget, every time you have to apply joins. But every time applying join is a bad way, because joins are costly in execution. Got it? That's why at the time of loading into my target only, I will denormalize the content. I will join the content and then finally I will load into my targets. Whenever fully joined content is loaded into target table, next onwards, no need of joins. Got it? For example, in the employee file, what is the schema in the employee file? What you have checked? ID, name, salary, gender, and department number. In the case of department, I have ID, sorry, department number, department name, and location. What I want to do is, suppose I want to join like this. Within a single file, I want ID, name, salary, gender, department name, and location. Okay. For example, first employee is 101, name something, salary something, gender male. He is from 11 department. 11 means marketing. And he is from head. Whenever all the information available in a single file or single table, next time onwards, directly you can query the data. No need to apply joins. That's why apply join at the time of loading into the target. Next onwards, directly query the data. Understood? Okay. So these two things we are going to do. Now, after completion of in the climax, maybe it may take other day session, one more day session also for all the scenarios of this join. We will mix unions with joins. We'll make it as a complicated scenario. So please wait till then. Today we understand how to apply the different kinds of joins here. Basically, these joins, three types. But in SQL, in ADF, these joins are four types. Number one, inner join. Number two, left outer join. Sorry, here not four types. Basically four types. Here five types additional in ADF. Number two, left outer join. And number three, right outer join. And number four, full outer join. And number five, which is cross join. Got it? So we will be seeing all the related scenarios of all these types of joins. First, I am going to talk about inner join. Inner join means it joins the records matching with the given condition. Joins the records matching with given condition. That means all matching rows will be joined. Final meaning is all matching rows will be joined. But suppose my condition is EMP dot department number is equal to DEPT dot department number. That means 11 record will join with 11 only. 12 with 12, 13 with 13. But left side, 2021 records are there. But right side, there is no 2021. Those records will not join. At the same time, right side, you have 14, 15. 14, 15 are not available in left side. Those two records will not join. That is the meaning of inner join. So how exactly the inner join? I am not going more theory. If you want theory, go for SQL basics. Straight away, I will come to the practical part of it. Okay. So this session as the first session we will dedicate for inner join. I will do it as a separate recording. All of you please observe. Already we started our studio. Fresh data sets I'm going to take for these two. Your data source is data lake. Gen 2 I am selecting delimited file. Okay. DS underscore join EMP. Because with EMP name, a lot of data sets are there. To avoid that confusion, I am giving like this. Linked service, already we have it. Selecting the first row as header. The file path, the first file, very first file I will give. Where is that? Under my data, EMP. Okay. Data set is created. Just I'm previewing the data. Okay. The columns have been taken. Of course, null values are there. I'm not going to clean the null now. In the final climax scenario, okay, we will apply that cleaning and all the concepts we will try to include into that. And meanwhile, sir, we will start data flow debug mode first because it will take time to start. Okay. Meanwhile, it will be keep running. Come back to the data sets. One more data set. This is also for data lake. Continue. DS underscore join DEPT. Okay. Linked service, the same previous linked service because both are in same storage account. Here also first row header, the file path. Our file is DEPT join. Finally say okay. So please preview the data. Whether header is taken or not, just confirm it. Preview. So here three fields: department number, description, and location. Okay. Okay, fine. I'm publishing this today. Okay, one more thing. Already we have a data set output. In our previous example, we have used, that's why output data set I am not creating. I will use that one. Just publishing these data sets. We cannot publish because your data flow is not complete. Previously, you started one data flow, right? That is DF floor. Just I will remove this. Later we will do that. I think what happened to the debug mode? Okay. Publish. All data sets ready for you. Now create your pipeline. Before pipeline, design our data flow. This data flow, I'm keeping it as inner join example. Inner join DF. Okay. Sir, you have two input files, two sources that you require. That's why this is source one and this is for source two. In the source one EMP, the source to DEPT. The source one. I'm going to configure that. Out stream name is EMP. Data set is DS underscore join EMP. And go for the projection and check it. Based on the department number, I want to map in the file, in the target file also. That is, this department number is string. Now no need to check no need to convert the data type. For example, file is from a data lake. Second file DEPT is from a table. In the table, department number is a integer. Then you have to convert this. Got it. So for now, in this, especially in this example, no need of converting. Okay, if necessary, we will convert that. Luckily, debug mode is also started on. And second source I am going to configure. This is for DEPT. The source, outstream name DEPT. Data set, DS underscore join DEPT. Is done. Both are configured. So for the first one, I'm going to apply a join transformation. Okay. So just I'm adding the transformation, which is join.
Excuse me, sir.
Yes, sir.
How do you know, sir, convert into integer or string?
So that is simply based on, suppose this is from file, this is also from file. Whenever
Okay.
you are taking reading data from files, everything is by default string.
Okay.
Already, if you don't know, just go for the projection and observe, check the data types.
Okay.
Okay. Suppose first file is from file, but second data set is from a table. In that table,
Okay.
data type might be different. Suppose in the table department number is integer, in the file department number is string, just convert that.
Okay, sir.
Okay. Suppose if you don't convert, it will give you some error. By seeing that error message also, you can modify that.
Okay, sir.
Okay. Now come to the join. I just came to the join. Observe here, we discussed the 5 types of joins for here. So inner join, left outer, right outer, full outer, cross join. Okay. So for now, we are going with only inner join. The default selection is inner join. That means 11 to 11, 12 to 12, 13 to 13. Remaining records will not join. Only matching records will be joined. Got it. Yeah. So for the joining, what is the left stream? What is the right stream? You need to say. Left stream is EMP, right stream DEPT. Okay. Based on what column the joining should happen, the condition. Left side, the employee dot department number. Right side, department dot department number. Okay. I am giving that column. You can select department number. Here also you can select department number. Got it? So only what is the joining column that you have specified, what condition you want to apply, equality or non-equality. Suppose 11 should not join with 11. 11 should join with others. At the time, go for non-equality, maybe greater than or less than or not equals to any condition. So, but in this scenario, we are expecting equality. 11 record should join with 11 record only. Okay. This is completed and you can check the preview. Observe here, there are many fields. Check clearly. Before writing into the sync, just check the preview. Just try to bring all the things into the near. After name, salary, and then gender I have. Still other things. This is just for comparison only, because I have two departments. One department from employee. Let me bring these two close. All of you, please observe the things. Especially observe these two columns. 11, 11, 12, 12, again 13, 13. That's it. There is no 2021. No 2021. And no 14, 15. Only 11, 12, 13. This is what the joining functionality of inner join. Okay. Okay. Still in the same recording, I go with the other types of joins output. Please check. Number 2, I am going for left outer join. Okay. All matching rows with the given condition. Plus non-matchings from left side. Left side is EMP. What are the non-matchings from left side EMP? Left side 2021. All matchings will come, all non-matchings from left side. That will come. Okay. Please check this. I'm going to configure left outer join into the same data flow. I'm not going with the other data flow. Just go to the join settings. Join settings. Here I'm changing left outer. Okay. Only join type you have changed. Just preview this. Refresh. Especially observe the departmental columns. You can understand what has been mapped perfectly and not mapped. Look at these two columns. 20. Look at this row 20. 20 available in left side, but not available in right side. But all matchings 11, 12, 13 matchings. 11 appeared, 12 appeared, 13 appeared. 20, 21 also appeared, but right side there is no information. That's why the right side fields nulls. That means no information missed from left side. All of you understood? This is left outer join. Got it. Tomorrow, if the question is like, so in what situation this will be helpful for you? What are those situations in the scenarios I will explain? At what situation that you have to use left outer join? Got it. Tomorrow, if I have a question like, what are all the departments? Like, my question meaning is, for some time, just treat it is department as a project, sir. Department as a project ID. There are 20, 21 projects are there. So for the 20 and 21 projects, 2 people are recruited in the employees as employees, but projects not yet started. That means that these 2 people are on bench. Understood? At the same time, if you look at 14, 15 projects started, but no employees in that project. Got it? You can label them as bench projects. That means projects without team. And a team without project. And there are some people 11, 12, 13 already started projects. For that, team is available. Okay, such kind of analysis you want to perform. Okay, finally, after completion of all types of joins, you will be seeing that scenario. Within that, lot of cleaning activity. Okay, and a lot of other transformations you will be seeing. Okay, so simply, what is the meaning of left outer join here? All matching rows and non-matching rows of left side. Still, I am going for other type of join, which is right outer join. Simply a small change to the above statement. All matching rows plus non-matchings from right side table. So whenever right side entities appeared, left side non-matchings will be missed. In the previous example, right side non-matchings missed. Here, right side non-matchings will be presented, left side non-matchings 2021 will be missed. That is what departments will be appeared here. 11, 12, 13 common. Those will be appeared. 14, 15 right side non-matching. That will be appeared. But for the 14, 15 left side information is empty, nulls. Understood? Okay. Just do the change and test it. Go to the join settings. Change your join type, right outer join, and preview, refresh. Now expected content 11, 12, 13 and 14, 15. For the 14, 15 left side information should be null. Please check at only department numbers. Look at last. 14, 15 are non-matchings from right side, but left side information, nulls. No ID, no name, no salary, no gender, and no department number for the left side. Got it. I'm going to work on full outer join this time. If you mix the left outer, right outer, you will get full outer. That means complete information will be available to you. Got it. That's why while denormalizing the data, you are going to apply full outer joins, especially in the warehouse. Okay. Number 4, full outer join. That means all matching rows plus non-matching rows from left and non-matchings from right. So these things you will be getting. So you will get 11, 12, 13, 20, 21 from left side, 14, 15 from right side. Complete information is available. That is advantage with the full outer join. Just let me apply this full outer join. Go to the join settings and change the join type, which is first one. Just preview and refresh. Okay. Look at last at the departmental levels. 11, 12, 12, 13, 14, 15 not available in left side. 14, 15 not available in left side. That's why left side information now. 20, 21 not available in right side. That's why that information is now. Understood the points? So this output, if you want to write, you can write into the targets. So I'm going to write this output into the target. What happens, you please check. And here the column name department number, here also the column name is department number. You want to modify them, add select column for this. Select a transformation for this. If you want to change the column order or something. Understand? Hmm. Observe this here. I want to do something in the beginning. Okay, let me check. What I want to show you here. ID, name, salary. The mapping is already there. Department here. EMP at the rate department. On that as a separate column, it is giving. As a separate column, it is giving. And DEPT at the rate department number as a separate column, it is giving. Okay. But here, it will be titled as DNO. If you want to change it, make it as one thing as DNO1. Second one, DNO2. Understand? DNO1 for employee, DNO2 for department. Later you can compare. Or else if you want only one thing, just you can drop any one column. But if you drop some information you are missing. Okay, some information you are missing. For now, I'm not going to clean anything. I just changed the labels and then I'm going to write into the sync. The sync transformation. In the place of sync, let's give our output data set. Already we have one folder, one container for output. That is the ds underscore output. Already it has some existed files. I want to clean them. So previous files will be deleted. I want to write into a single output file. Set single partition for this. And file name, EMP DEPT, because both the content I have joined here. I'm going to publish this data flow. Data flow published. Now create your pipeline. A new pipeline. Join pipe 1. Drag the data flow activity. So previous work is what, sir? Previously what you have done? Mapping data flow. This is data flow activity. Previous one, mapping data flow. This is data flow activity. Okay. So in the data flow activity, just configure our data flow name. The data flow name we have given. What is the name we have given? So not here. Here, data flow under settings, inner join DF. Of course, we have applied actually full outer join. Okay, but we have given the name like that in the beginning. Okay, that is configured and then debug this. Now flow starts executing now. Status is Q. Okay, it's done. Please check the output file. Under output, you have DEPT, which is our output file. Check the data of it. Department is repeated for 2 times because you selected those 2. Okay. So just for making bigger size and test on the notepad about this file content. First line is header. Second thing, 11, 11, 12. What happened to this? 20 not available in right side. Department 20 is not available in right side, sir. Look at 106 all of. Understood? And also 21 also not available in right side. Got it. 13 is matching, 13 matching. But what about 15? Not available in left side. 14 also not available in left side. So no records missed. Got it.
Why coming extra comma?
Where?
There is extra, lot of extra comma is there.
Not extra comma, man. This is for description. This is for department number, second department number. This is for description. This is for location. Where extra comma? Where our information missed? Just null value. That means blank value. When blank is taken into ADF, the blank is converted as null. In ADF, that is null, but in the file, that is blank. Understood? It's not extra comma. Those values got missed. Right side department missed, description missed, location missed. After location, there is no comma because there is no next field. Location is the last field. Understood? Come on here, observe the before 15. Here first ID missed. Here name missed. Salary missed. Gender missed. And left side department number missed. No extra commas, right? All of you understood? Just in the place of value, just blank is written. Yes, sir.
Quick question. If the volume of data is high in the initial data sets, considering the data factor typically use partition mechanism for like
yes,
outputting the processing the data.
Yes.
Like what are there any precautions or like
nothing, just to go
ordering
for
of data required?
No ordering of the data required here. Better if file volume is huge. In data flows, you cannot control your clusters properly. Because how many nodes that has to be engaged into that one? How many parallel processes have to be triggered into that one? You cannot control in such a way. In that moment, such kind of process performed by using Databricks Spark job. In Spark, for a data set, runtime, you can decide how many number of partitions are required for that. Okay. So according to that, automatically, according to our cluster size, the process will happen. Of course, data flow is also finally converting our job into Databricks also. But you cannot optimize it way. In optimized way, you cannot control that. Got it? Yeah. Okay, sir.
There is no matching column. How can be joined?
Pardon?
There is no matching column. How can be joined?
You cannot.
It's not possible.
You cannot. There should be some clue to join. Understood?
But some interview asking without matching column, how can be joined?
That is what, man, I'm saying. If name is there, age is there in one file. In second file, name is there, city is there. Suppose not city. If it is like this, Ravi 20, Rani 30. Here think that this is the city of the Ravi, which is Hyderabad. City of the Rani is Delhi. Now, on what basis that you will join? additional techniques that you have to use, not by the techniques of basic joins. Understood? In this case, apply a surrogate key for this one. Here surrogate key 1 and here 2. Apply the same surrogate key here because you are not authorized to touch the tables data. Runtime, apply the surrogate key. Now 1 to 1, 2 to 2 record has to be joined. This is in this scenario. Maybe in another scenario, other different technique. Everything ADF will not do, sir. The ADF developer brain has to do that one. Understand? Don't expect all the things from the ADF. Just pushing your file, your expectation is done. Don't expect like that. Interviewer doesn't have any work. That's why he is asking so many questions. But only your brain has to say answer, not ADF. Sir, clear, sir?
Yes, yes.
So whenever you have generated a surrogate key, make the surrogate key as joining column now. Previously some clue missed, now you got some clue. Apply that clue. Okay. Yes, sir.
Yes, yes.
We will start next scenario in the next recorded session.